Let's just title it remainder theorem. Also known as factor theorem sometimes, but I don't feel like writing that all out. So remainder theorem. Okay. So first thing we're going to do, kind of like a warm-up problem-esque, is we are going to do long division on what is 3x squared plus 8x minus 4, and we're going to divide this by x minus 2. So what I want you to do in your groups, people in person anyway, if you want to work in groups on this, I want you to use long division on this to find the answer. All right, if you want to compare it to what I got, you can look up. I'm not trying to spoil anyone's fun there, but sometimes people get mad if I show them the answer while they're still working, so you don't have to look. Now, you might be wondering, why are we going over this if we are on remainder theorem? Because I want to show you how remainder theorem works. So what I'm going to say here is that f of x is equal to this numerator. Okay, I'm just making that up. And what I want you to do is find what is f of 2 equal to. You should notice something. By the way, I picked the 2 because this right here, if you set this equal to 0 and solved, x would be equal to 2. You should get 24. Okay. So if you do long division, it tells you the remainder here. Or if you use remainder theorem, it tells you the remainder here. Okay? So if there's ever a problem and it says, what is the remainder? If you divide these two polynomials, you can just do remainder theorem on it. You just got to figure out what number to plug in. In this case, it's that 2. Okay? To figure out what that number is, you just set the denominator equal to 0 and solve. X is equal to 2. You throw the 2 into the top equation wherever there's an x, and then you will get what the remainder is. Okay? That's what remainder theorem is all about. If you plug it in directly, after you do that x minus 2 equals 0 and solve for that, it will tell you what the remainder is. Pretty much all of remainder theorem. Now, if the remainder is 0, that means that whatever is on the bottom is a factor. Okay, this one is not a factor because the remainder is 24. Okay, so there will be certain questions on your practice problems that say, is the following a factor? And you would say no, because there's a remainder. Okay, so if the question was, is x minus 2, is this thing right here a factor of the top one? And you'd say no. Let's say that g of x is equal to x cubed minus 3x squared plus 6x plus 8. Okay, we're going to divide this by, or here, I'll just say, is x plus 1 a factor of g of x? So it's going to be a yes or no answer, and then you have to like prove it, like prove your answer. So I'll write justify your answer. Justify your answer, which means just show work. Okay. So I got the remainder to be negative 2. So does that mean, is it a factor, yes or no? No. Very good. So the answer for this one would be no, and then the justification would be because g of negative 1 is not equal to 0. Okay, it's equal to, you could have even written g of negative 1 is equal to negative 2. That shows that it's not a factor. If it was equal to 0, then it would be a factor. The reason for that is because if there's no remainder, that means it divided through evenly, essentially. You will be given a question that's like this on the test. There's also numerous on the practice problems that are like this as well. But just make sure you either wrote it down or made a mental note. If, when you plug in that negative 1, if it was equal to 0, then it would be a factor. Otherwise, it's not a factor. Does anybody know how many factors should I have for this problem here? Based on this power right here? 3. Okay. And one of them is not negative, or x plus 1 is not one of them. Fundamental theorem of algebra. Now you might be thinking, well, what are they? Can we go over them? Yeah, we will eventually. It's just not important right now. Beyond the scope of the class, essentially. All right, I'm going to try to give you a curveball one now, okay? But don't get mad. This is going to be crazy. Okay, it's going to be very closely related to the one we just did. So say I had a problem that was like this. Let's just call it p of x because it's a polynomial. And let's say it's x to the third plus kx squared plus x plus 6. Okay? And I'm going to say that x plus 1 is a factor of p. Okay, x plus 1 is a factor of p. If that's true, then it is true. But based on that, what is the value of k then? I feel like we should do this one together. Is anyone going to be against that? X plus 1 is a factor of p. That means p of what is equal to 0? What do I need to put as my input for x where this is going to be equal to 0? If x plus 1 is a factor, anybody?
-1.
-1, thank you. Remember, it's got to be the opposite. Thank you for whoever said that. You do x plus 1 is equal to 0, you solve x is equal to -1, so you throw the -1 in there. So it's almost like the opposite of what's there. All right, well, that's awesome. Let's plug in -1 to this thing and see what we get. So p of -1 is going to be equal to -1 to the third plus k times -1 squared plus -1 plus 6. Okay, and if you notice, we're solving for k. That's the only variable that's there, so we should be able to solve this. So this is going to be 0 is equal to -1 plus k, because this is just going to be 1, -1 plus 6. Okay, we're going to add the 2, the 1 and the other 1 over there to be 2, and then subtract the 6, so you should get -4 is equal to k. So that is the answer for this one, because it says what is, you're solving for k, so k is equal to -4. Okay, well, we're gonna do an extension on this now. Okay, I'm gonna ask other questions based on this. So x plus 1 is a factor. How many factors should there be based on the power, based on the degree? 3. We are gonna find those other 2 factors. So we found 1, which is x plus 1. We're gonna find the other 2 now. Okay, this is going to lead directly into the next thing we're doing, 2, 2, 3. So I'm kind of giving you a brief intro of it, but I just want to show you how all this stuff is related. Okay, so we have one of the factors right here, but there should be 3 technically. So that's what we're going to find. First thing I'm going to do is I'm going to rewrite that equation. So x cubed plus, oops, I'm not going to do plus though because it's a -4. So -4x plus x plus 6. So I replace this k right here with the -4, essentially. Okay, now this has a factor of x plus 1. So guess what I'm going to write here? X plus 1, I'm going to divide it out. Okay, when we divide this out, you're taking away an x from this x cubed. So that means how many x's are we going to have left if we take out 1? 2, because then that's going to be x squared. If it's x squared, that means there's going to be 2 answers to that, which means there's 2 factors, which is the other 2 factors that we're looking for. If you remember, there's 3 total. One of them is x plus 1, so we just have to find the other 2. Okay? So what I want everyone to do here is, again, it's going to be a review of long division, but do a long division on this blue right here. Okay? We are looking for the other 2 factors. This will help us find those factors because we're taking out one of the factors. We're just taking out the x plus 1. And what's left, you'll have a quadratic. Once you have that quadratic, you should be able to factor it and find those other 2 factors. And then we're going to have all 3 factors, which is what we should have. And look at that, it is a factor because the remainder is 0, which is what you should get. Okay, so now we're left with x squared minus 5x plus 6. Okay, and we're looking for the other 2 factors on this. There's 2 main ways you can do this. You can either use quadratic formula or you can just factor it the old-fashioned way. Which do you prefer? Does anyone want to just, what do you prefer? What way do you want to see? No preference? All right, well, then we just think what two numbers multiply here and add here. The two numbers would be -5 and -3. So you can just factor it out to be x minus 2. All right, so the other two factors would be those two things right there. Okay, and I'm realizing now I covered up the original problem. So let me go back to a different background color. Let's do... But anyway, the answer for this one for the other two factors would be right over there, right here. Okay. So essentially, P of x is equal to the following. Okay. So P of x is equal to that x cubed plus -4x squared plus x plus 6, but it's also equal to, in factored form, x plus 1 times x minus 2 times x minus 3. You should have 3 factors because it's x to the third, and that's basically the answer for that one where it's completely factored. Okay. We are going to be doing this in way more detail later on, so I'm just kind of preloading something in your brain, so when you see it the next time, it'll make more sense. All right, from here, I'm going to kind of review multiplicity a little bit, and then I can kind of leave you alone here. So say we had some function where this was the equation for the function. Cubed times, let's just do x. Okay. The question on a quiz would be, based on f of x, what would the graph look like? Okay, again, we've done this before, but it's just good to do again. What would this graph look like? Just graph a brief sketch of what it would look like. Okay. First thing that you want to do is find all of the x-intercepts. So you're going to be setting this equal to 0, this equal to 0, and this equal to 0. Okay. Everything is already factored, so it should be pretty easy for you to try to figure out. So this first term right here, whoops. This first term right here, not term, this first factor right here. It's really two factors. What x value would cause that to be 0? Just yell it out. X minus 1. What x value, if I put in there, it would be equal to 0? 1. So 1 is going to be 1 of my x-intercepts. Okay. What about this second one right here? This factor right here that has a multiplicity of 3. What would that be? -3. Thank you. And then what about the last one? This x right here. If I set that equal to 0, what's my x equal to? 0. That's the easiest one. Okay, so we have the 3 y-intercepts. Okay. Now this one has an even power, so that means it's an even multiplicity. So what is going to happen at 1 there? If it's even, does anyone remember? Is it going to go through it, or is it going to bounce? Bounce, thank you. Okay, it has to bounce going up this way because it's a positive leading coefficient. The leading coefficient is positive. There's no negatives here. So it has to go there, so it has to bounce this way. If you drew it like this, don't draw it like this, but if you drew it like this bouncing, you're technically wrong because now you're going in a negative direction when you should be going in a positive direction. Make sure you get that right with that. You'll still get points for the bounce, but you would lose it for the leading coefficient. All right, the x, the multiplicity of this one is 1, so that means it's going to go right through it. So I'm going to go right through it. And then this one is a 3, so -3. Is it going to go through it, or is it going to bounce if it's odd? It goes through it, right. It kind of flatlines a little bit to go through it, and then it goes up. Okay, so rather than just going like straight through it like here, it kind of dips a little bit. And that's all I'm looking for on this, okay? If you notice the powers, if you add them together, 2 plus 3 plus 1 is 6. So that means it should match on both sides. The ends should match, which they do. They're both going up. They're both positive. There's no negative in there, so that's right as well. So that would be full credit for that.